Welcome back, Algebra 2 Trig Honor students. So this one is the day 4 lessons. So today I would like to talk about the standard form and the coterminal angles. Okay, so for part 1 of coterminal angles. So coterminal angle is just finding the, kind of like finding the auxiliary angle. So to find a coterminal angle, so either you want to add 360 degree or you want to subtract 360 degree, either once or multiple times. So it depends on how large the given angle that is, okay? So coterminal angles are equivalent angles since they share a terminal size. So that means, well, imagine that, let's say we go around the unit circle or we go around the circle once. So let's say that I go around the circle once, so that means you want to rotate 360 degree. So that means you're going back to the exact same positions. So after you go around 360 degree. So for example, let's say like merry-go-round, Ferris wheel. So let's say that you go around 360, taking the right 360 degrees. So that means you're going back to the exact same position. So basically, coterminal angle, it's the same kind of idea that we want to find out the angle, so which you'll end up with the same terminal side. So let's say that a given angle is negative 45 degrees. So in order to get the positive coterminal angles, so we want to add 360 degrees. So then that would be considered 315. So this one's supposed to be equal sign here. I don't know why it's missing a bar. Okay, so negative 45. So in order to get the negative coterminal angle, so we want to subtract 360. Then you'll get negative 405 degree. So 395 is a big angle. So in order to get the positive coterminal angle, so we want to get that smaller. So you want to subtract 360. So it's 35 degree. So in order to get another negative angle, so you want to subtract 360 twice. So that's why 395 minus 2 times 360. So it's negative 325 degrees. So again, the illustration is showing that, you know, how it goes. Okay, so started off with negative 45, again, going by clockwise. So in order to get that positive coterminal, so you want to go back by counterclockwise. And then to get the negative, so you want to keep going 360 degree, you'll end up with the exact same terminal side. And then for this one as well, so started off with 395. So this one is going back to quadrant 1 and then getting the smaller positive angle. So that means you want to subtract 325. So going backward. Okay, so going backward right here. And then for getting the negative coterminal, so you just want to subtract 360 twice, okay? So find one positive angle, one negative angle are coterminal with the following. So this one, there's no need to draw any standard positions of the angle. So negative 60, so we just need to add 360. Then that'll be 300 degrees. And then to get the negative coterminal, so simply subtract 360. So negative 60 minus 360, then that'll be negative 420 degrees. And then the other one is quite similar, so let's take a look at the one with the negative radian. So negative pi over 3, so in order to get the positive coterminal, so we add 2 pi, because 360 degree, that's just like 2 pi. So negative pi over 3 plus 6 pi over 3. So then that would be considered 5 pi over 3. To get the negative radian, so negative pi over 3, negative coterminal, so minus 2 pi, so negative pi over 3, minus 6 pi over 3, then that would be negative 7 pi over 3. Alright? Again, B and D, those are the one you guys can follow through the exact same example. Evaluating in standard form. So let's talk about that, the equation of a circle. So let's say that we do have an equation of a circle. So let's say the center is at the origin. Okay, so right here at the origin. And we do have a terminal side right here. So let's say this one is x comma y. And here's the radius. And here's the angle. Let's say theta. I don't like this diagram here because this one shows that it's in quadrant 2. Okay, so let's say that it's in quadrant 1. And we do have a right triangle here. It just, make the vertical dotted line all the way down to the bottom. Okay, so if you try to zoom it out, so for the right triangle, so we do have radius, which is the hypotenuse. And the point here is x, comma y, so that means the distance here is what? X. Here's y. Here's theta. So you might be wondering, theta is the base angle? Indeed, yes, it is. So x would be what? The adjacent. And then y, it's the opposite. And then r, it's the hypotenuse. So in order to get those ratios, sine, cosine, tangent, so we do know that sine of theta is considered opposite over hypotenuse. So in this case right here, in terms of x, y, r, so this one can be written as y over r. Okay, so for sine of theta, could be considered y over r. And now, what about for cosine? Cosine of theta, so using the same ratios, back to what we did for day 1, so that it's considered adjacent over hypotenuse. So in this case right here, we're using x, y, r instead. So that means adjacent is what? X. Hypotenuse r. So it's x over r. And then what about for tangent? So tangent of theta. So back to what we did before, it's considered opposite over adjacent, the trig ratios. So katoa. So in this case here, it's y over x. So this one is just the same kind of ratio, but we just want to use different kind of algebraic expressions. So in terms of the equation of a circle, which is what? X squared plus y squared equals r squared. Because at the center, it's right here at the origin, 0, 0. So going back to the standard form of the equation of a circle. So x minus h quantity square plus y minus k quantity square equals r squared. So if you guys do recognize that back to the conic sections, things that we have done recently. So that's the equation of a circle. But the thing is that it's a 0, 0 for the center. So x squared plus y squared equals r squared. And now what about the rest of those ratios? So the rest of those ratios, so this one is just the reciprocals of sine, reciprocals of cosine, and the reciprocals of tangent. So this one just reverse the order. So r over y, r over x, and then cotangent of theta, x over y. And make sure that, got to be careful with the ratios. We do know that the radius cannot be 0 because that's always greater than 0. If that's a 0 for the radius, that means just a point. So if the radius is not 0, but also we need to make sure that x and y cannot be 0 for those ratios. Because otherwise, that would be undefined. Okay? We'll get to that, once we deal with the undefined situation with the trigonometric functions. So now, let's do some example here. So use the given point on the terminal sides of the angle theta in standard positions to evaluate the 6 trigonometric functions of theta. So just plot the point first. So 6, 8, so that means 6 units to the right, and then up 8, so it should be somewhere up here. So you started at the origin, 0, 0. Okay, so 6, 8. And then you want to draw the triangle here. So this one, we do know that adjacent is what? 6. Opposite, it's 8. Hypotenuse, we don't know what that is, but we can use that, the Pythagorean theorem, to figure it out. So radius, we don't know what that is. So 6 squared plus 8 squared, and then square root of the whole quantity. So 36 plus 64, so that's exactly 100. So it's what? 10. So radius is 10. So step 1, you want to find out the missing element, either the radius or sometimes the value of x and y. And now you want to find out the ratio, so cosine of theta. We do know that's x over r, so which is what? 6 over 10. But don't forget to reduce, simplest form, so which is what? 3/5. Sine of theta, which is y over r, so it's a over 10. Reduce, so it's 4/5. And then tangent of theta, y over x, so then that'll be considered a over 6. So then that'll be 4/3. And then the rest of those ratios, so we do have secant, which is the reciprocals of cosine. So then that'll be what? 5/3. And then cosecant, which is 5/4. And then cotangent, reciprocals of tangent, then that'll be 3/4. And then the other one, so basically the same kind of procedure. Okay, so plot the point and find out the ratio. But this one, so there's some ratio that looks like it's going to be negative. Okay, so -3, 2. So -3, 3 units to the left, up 2 units. So somewhere up here. Okay, so try to draw the line segment or the terminal side. So let me just try this way. Should be straight, okay? It's not crooked. Okay, so all the way up here. So -3, 2. Again, it's a right triangle, as you can see. So -3 unit, 3 units to the left, 2 units up. Finding the hypotenuse, so we do have -3 quantity square plus 2 quantity square. So that equals radius square. So 9 plus 4 radius square, so it's 13. So radius is what? √13. And using the ratios, so x/r, so for cosine, which is -3/√13. And then don't forget to rationalize it. So multiply by √13 top and the bottom. So we do have -3√13/13. And then for sine, so similar. y/r, so 2/√13. So 2√13/13. And then tangent. Opposite over adjacent, so 2/-3. And then the rest of that, just find out the reciprocals to get secant, cosecant, and cotangent. Okay? Now, what about something like this? So let's say that we do have theta at 90 degrees, and theta is -pi. So how do we get those ratios? So for those you might be wondering. Okay, so again, we do have a circle. So let's say that the circle here, well, we got 0, 90 degree, here's 180, and down here's 270. So now, so anytime that the radius it's not given, so let's say the radius is not given. So we're assuming that radius, it's considered 1. So we'll get to that with the unit circle in the next sections. So radius is 1. Again, if the radius is not given, just the angle, so that means we're assuming it. Radius is 1. So that means at this position here is 1, 0. Right up here is 0, 1. So kind of like the Ferris wheel. Okay, so the Ferris wheel with the initial position down the bottom, and then it goes around 90 degree, 180, and then keep going like that. Okay, so all those positions. And then this one here, so -1, 0. And then down the bottom, guess what that is? So 0, -1. So again, this one is just a representation of the xy value. So using that, the ratio, what we did before, so cosine of theta, x/r, while x here, which is what? 0. So 0/1, because the radius is 1, which is what? 0. So cosine of 90 degree, so the ratio is what? 0. And now what about sine of 90? So sine of 90, the ratio is considered y/r. So 1/1, which is considered what? 1. And then tangent of 90, y/x. So it's 1/0. Guess what? We cannot divide it by 0 because that would be what? Undefined. Undefined. And then the reciprocal, so for secant of 90, so secant of 90, then that would be considered 1/0, which is undefined. And then cosecant of 90 is still considered 1/1. It doesn't matter which way that you flip, it's still considered 1. And then for cotangent of 90, so this time turns out to be x/y, so which means it's what? 0/1, so 0. And then what about for -pi? Same thing, so -pi, that means you're going back by clockwise. So it's reaching to 270. So we're using XY value, 0, -1. Okay, so try that one and see what happens. Okay, so for the reference angles, we'll get to that for the next video. So again, any questions, any things I need help, so just rewatch the video first, and then you probably want to pause and then take notes. And also, you're more than welcome to ask me questions on the YouTube channel. Again, if you guys do like the channel, so please subscribe and also click the bell. Appreciate it. So I'll see you guys next time. Take care.